Hello everyone, Dennis here. In this video, we are going to discuss GCE O-Level Physics October-November 2020 paper 2. Subject code is 6091. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Alright, now let's start discuss the paper. Question 1. A. Velocity is a vector quantity and speed is a scalar quantity. Give one other example of a vector quantity and a scalar quantity. 1 mark. Okay, so I hope you already understand what's the difference between vector quantity and scalar quantity. So you can just give any example of a vector quantity and a scalar quantity to answer this question. So for vector quantity, you can say it's a displacement or acceleration. And for scalar quantity, you can write it as distance or energy. So here, quick recap. Vector quantity is quantity that has a magnitude and direction, while scalar quantity is a quantity that has a magnitude only. B. Figure 1.1 shows the Singapore Flyer. A point on a spoke moves in a circular path at a constant speed of 0.24 meters per second. 1. Describe what happens to the velocity of this point during one complete rotation. 2 marks. Alright, so before answer this question, let's have a quick recap. What is a velocity? So a velocity is the rate of change of displacement. And what is a displacement? A displacement is the length between the starting point and the ending point. Hence, since the spoke moves in a circular path and after one complete rotation, it means that the spoke will go back to the original position. Hence, the displacement will be 0 after one complete rotation. Therefore, to answer this question, we can say that the velocity of the spoke will constantly change as its displacement is changing when it is rotating. It becomes 0 when the spoke completes one rotation as it returns to its initial position, where the displacement equals to 0. Next question, part 2. One rotation of the Singapore Flyer takes 30 minutes. The circumference C of a circle is given by the equation C equals pi d, where d is the diameter of the circle. Calculate the radius of the circular path and give your answer to an appropriate number of significant figures. 2 marks. So, we know that the circumference C has a formula of C equals to pi d. Now, we want to find the diameter of the circle, so d will be C over pi. Now, the circumference of the circle for this case will be the speed of the rotation, then multiply with the time. So the time is 30 minutes and we convert to seconds, so we have to multiply another 60 seconds as 1 minute equals 60 seconds, and then we divide it by pi. Then we calculate with calculator, we'll get this value is about 137.5 meters. And now to get the radius, just take the diameter divided by 2. So we calculate and we'll get 68.8 meters, rounded up to 3 significant figures. Hence the answer is 68.8 meters. Next question, question 2. A student throws a ball vertically upwards. The following sequence describes the motion of the ball. The ball leaves the student's hand at time t equals 0 with a velocity of negative 2.0 meters per second. It rises into the air until it reaches its highest point. It falls and hits the ground with a velocity of positive 4.0 meters per second at t equals 0.60 seconds. It is in contact with the ground for a very short time and bounces upwards. The student catches the ball at t equals 0.80 seconds when its velocity is negative 1.0 meters per second. The effect of air resistance is negligible. A. State what is represented by the gradient of a velocity time graph. 1 mark. Okay, so the gradient of a velocity time graph will be the acceleration. Hence, acceleration will be the answer. B. Part 1. On figure 2.1, draw the velocity time graph for the ball from t equals 0 until t equals 0.80 seconds. The initial velocity is marked as point P on the graph. 3 marks. So, to complete this velocity time graph, we need to plot the point one by one. So for the first point here, the ball leaves the student's hand at time equals 0 with a velocity of negative 2.0 meters per second. This already marked by the point P here. Okay, now we move on to the next point. It rises into the air until it reaches its highest point. So the keyword here, highest point, which means that V equals to 0. But the question is, when is it? What is the t value when V equals to 0? So for this case, we don't know yet. So I will just leave this point first. I'll move on to the next point. The next point is it falls and hits the ground with a velocity of positive 4.0 meters per second at t equals to 0.60 seconds. So based on this information, I can plot the graph at time 0.6. The velocity is 4.0, so positive 4.0 meters per second. Okay, then what I want to do next is I will join point P with this point with a straight line, and this is what we get. And as we can see here, when the time is 0.2 seconds, the velocity equal to 0. So this answer for the second point here. Alright, now move on to the next point. It is in contact with the ground for a very short time and bounces upwards. Okay, so when first it contact with the ground and very short time and bounces upwards, which means that it will start to change direction. With change direction, then the velocity will become 0. So remember, velocity is a vector quantity, so when change direction, its sign will change as well. Okay, now move on to the next point. The student catches the ball at t equals 0.8 seconds when the velocity is negative 1.0 meters per second. So based on this information, I can plot this point over here. When time is 0.8 seconds, the velocity is negative 1. Okay, so now the next thing we need to know is right after it reach here, when it change direction, what is the velocity? So to get the velocity, we need to use this formula, the initial velocity, right? So V equals to U plus AT. So V is the final velocity, U is the initial velocity, A is the acceleration, T is the time. So I want to find the U equals V minus AT. So the V is this velocity, which is negative 1. The acceleration is negative 10. So this is the gravitational acceleration. Okay, so it bounces up, that's why the acceleration is negative. And then the time, how to identify the time? So this is the time from 0 to 6 seconds to 0.8 seconds. So the time is 0.2 seconds. So I substitute t equals 0.2 into the formula here, and then I calculate everything. I get the initial velocity is negative 3 meters per second. Now I can mark when the time is 0.6 seconds, it changed from positive 4 meters per second to negative 3 meters per second. So as described here, it contact with the ground for a very short time and bounce upwards. Okay, when it bounce upwards, then velocity becomes negative. Now I can join these 2 points together with a straight line. So by doing this, I complete this velocity time graph. Part 2. On figure 2.1, mark with a letter X the point where the ball reaches its maximum height. 1 mark. Okay, so this is described in point number 2. It rises into the air until it reaches this highest point. So when it reaches the highest point, as I mentioned just now, it means that the velocity equal to 0. Okay, so from this diagram, just now we actually skip this point, we move on to the next point, right? When the time is 0.60 seconds, the velocity is positive 4.0 meters per second. Then I mark this point and I join point P with this point. Okay, so now from here we can clearly see that when the time is 0.2 seconds, the velocity is 0. Hence, we can mark this point as point X. Question 3. Figure 3.1 shows a man using a device called a jetpack. Gas is forced downwards from the jetpack to create an outward force. A. State in terms of the forces acting while the man remains stationary in midair. 1 mark. Okay, so the keyword here is remain stationary. So since we can see this keyword stationary, we can relate it to Newton's first law, where this law states that an object at rest remains at rest and an object in motion remains in motion at constant speed and in a straight line unless acted by an unbalanced force. So this man is in stationary, so it means that the resultant force is 0. So to answer this question, we can say that the outward force created by the jetpack is equal to the downward force due to the weight of the man. The resultant force is 0 and hence he remains stationary in midair. B. The jetpack has a weight of 160 newtons. The man has a mass of 75 kilograms. 1. Distinguish between mass and weight. 2 marks. So to answer this question, we can distinguish between mass and weight at this different perspective. Now we can talk about the definition. So the definition for mass is the amount of substance of a matter, while the weight is the gravitational force acting on the matter. And we also can talk about the types of quantity. So the mass is a scalar quantity, while the weight is a vector quantity. We also can talk about the characteristics. So mass of a matter is always constant, while the weight of a matter can change depending on how much the gravitational force acting on it. Alright, so since this is a 2-mark question, maybe you can just mention 2 differences between the mass and the weight. Part 2. Calculate the total mass of the man and the jetpack. The gravitational field strength G is 10 newtons per kg. 2 marks. Okay, so from this question, we already given that the mass of the man is 75 kilograms. And for the jetpack, we only have the weight of the jetpack, which is 160 newtons. So we have to convert this 160 newtons to kilograms. Okay, so to convert it, we use this formula, weight, which is the which W is equals to the mass M times the gravitational field strength G. Okay, so to find the mass, it will be the weight divided by the G. So the weight is given 160 newtons and the G is 10. So the mass of jetpack will be 16 kilograms. Therefore, the total mass for the jetpack and the man will be 16 plus 75, which is 91 kg. Hence, the total mass will be 91 kg. Part 3. The man increases the outward force and there is an acceleration of 0.20 meters per second square. Calculate the outward force produced by the jetpack. 2 marks. Okay, so for this case, right, since the outward force is increased, then the resultant force will be unbalanced. Okay, so since it is unbalanced, we can use Newton's second law, where the resultant force F will be equals to ma. Now, the mass will be 91 kg, which we have calculated in part 1, in the previous part, and then times with the acceleration 0.2 meters per second square, and we'll get 18.2 newtons. Now we can update on this free body diagram. So resultant force is 18.2 newtons. The weight is the mg, so where the m is 91, so the total mass multiplied with the g, which is 10, and we get 910 newtons. So update here, 910 newtons. So what we need to do is we need to find the upward force. So the resultant force here will be equals to, for this case, since the upward force increases, that means this upward force is greater than the downward force, which is the W. Okay, so then the resultant force F will be equals to upward force minus the weight. So rearrange this equation to get the upward force and equals to the resultant force F plus P the weight. So substitute the values. Resultant force is 18.2 and the weight is 910. We'll get 928.2 newtons. Therefore, answer is 928.2 newtons. Question 4. Figure 4.1 shows a shuttlecock just as it is hit by a badminton racket. As the racket hits the shuttlecock, work is done by the racket. A. State what is meant by work done. 2 marks. Okay, so this is very textbook based question. You just need to write down the definition of work done, which is work done is the product of force applied on an object and the displacement traveled by the object due to the force in the same direction of the force. Or the formula of work done, WD equals to F multiplied with the distance, same direction with the force. B. The path of the shuttlecock after it is hit is shown by the dashed line in figure 4.1. The shuttlecock is moving fastest just as it leaves the racket. It slows down until it reaches point Y. Describe the energy changes from the moment the shuttlecock leaves the racket until it reaches point Y. So this question is a 3-mark question. So you have to be careful, okay, because it is a 3-mark question. So you need to understand what the question is asking. So the question wants you to describe what are the energy changes in this example here. Okay, so that means you have to mention a few energies that involved in this case. All right, so there are a few keywords that you can pay attention. Right now we look at this sentence. The shuttlecock is moving fastest. All right, so when move, that means we have velocity. So what energy will be related to velocity? Okay, it is the kinetic energy. Okay, remember kinetic energy formula is half mv squared, right? So the v is the velocity. And then another energy that you need to mention, right? You look at the diagram. As the shuttlecock travels from this point to point Y, right? The position of the shuttlecock has changed. So at this point it is higher, at this point Y it is lower. Okay, so change the position from higher level to the lower level. So this involves the another type of energy, which is the GPE, the gravitational potential energy. So the first point we can mention is as the shuttlecock falls towards the ground, its gravitational potential energy changes to kinetic energy. Okay, now another point is it slows down here. Alright, so slows down means that the velocity has reduced. Okay, when the velocity reduces means that the kinetic energy also has reduced. Now the question is, where has the kinetic energy transformed to? Okay, so the answer is, as it slows down, work is done against the air resistance. Okay, so it is due to the air resistance. That's why the kinetic energy, right, is getting lower. Okay, hence some kinetic energy is converted to the thermal energy and sound energy. Okay, so this will be the answer for this question. C. The shuttlecock has a mass of 5.0 times 10 to the power negative 3 kilograms. At one part of its motion, the kinetic energy of the shuttlecock is 0.36 joules. Calculate the speed of the shuttlecock at this point. So, 2 marks question. Now, since this is a kinetic energy question, we use the kinetic energy formula, which is half mv squared. Then we substitute all the values given. Kinetic energy is 0.36 joules. The mass is 5.0 times 10 to the power negative 3 kg. So we solve this equation. The V squared will be 0.36 times 2 divided by 5.0 times 10 to the power negative 3, which is 144. So V will be square root 144, which is 12 meters per second. Therefore, answer is 12 meters per second. Question 5. Figure 5.1 shows part of a filament lamp. The connecting wires pass current to the filament. A. The connecting wires are thicker than the wire used for the filament. The filament glows brightly, but the connecting wires do not glow. Explain why. So 2 marks. Now, before I want to answer this question, let's recall two formulas. The first formula is the resistance formula, R equals to rho L over A, where rho is the resistivity, it is a constant, depends on the material. The length L is the length of the resistor and A is the cross-sectional area. So from this formula, we can see that the resistance is inversely proportional to the cross-sectional area. And another formula that we need to know is the dissipated power, which is I square R. So based on this formula, as you can see, when the resistance is higher, that means the dissipated power will be more as well. So these two quantities are directly proportional. Okay, so next let's study the question here, right? They say that the connecting wire pass current to the filament. So this means that, right, the connecting wires are connected in series with the filament. So why is so important to mention this sentence? Because hence the same amount of current flows through them. Okay, so we need to make sure that the current flows through the connecting wire and the filament is the same amount. Okay, it cannot be different because as you can see, right, if the current is different, then the dissipated power will be different as well. Okay, now the next point is we talk about the thickness of the connecting wires and the filament. Okay, so thickness means the cross-sectional area of the wire and the filament. Okay, so now we can say that since filament is thinner than the connecting wires, right, hence it has smaller cross-sectional area. Okay, so A is the cross-sectional area, which means that it has larger resistance than the connecting wire. So what does it mean? The R is more, as I mentioned just now, the dissipated power is also more, right? So then we can say that when the current flows through it, the more power is dissipated in the form of heat and hence produce the light. Okay, so actually this is how the filament lamp works. B. Describe how thermal energy produced by the filament is transferred by convection inside the lamp. 3 marks. Okay, so for this question, we have to describe how the energy or the thermal energy is transferred by convection, okay, inside the lamp here. Okay, so answer should be description how convection happens in the filament. Okay, so first point you can mention is that thermal energy from the hot filament is transferred to the surrounding air and the air expands. Okay, the next point, so since it expands, what happened? The density of the heated air decreases. Okay, so when the density of the heated air decreases, it will rise. Okay, so the cooler air from the top of the lamp has higher density and hence it sinks. Okay, so when hot air rises, the cool air sinks. And then when it sinks, is to fill up the empty space from the heated air. Okay, because the heated air has rise. Now, the cooler air, what happened? It will receive thermal energy from the filament and then it expand again, right? So this causes its density to decrease and hence it rises. Alright, so what happened next? Of course, the process will repeat, right? The hot air will rise and then the cool air will sink. Alright, so again, when sink get heated, then it expand, rise again. So the process will repeat. So this will create the convection current flowing inside the lamp. Okay, so this word convection current is a very important keyword when you want to describe convection. Okay, so this will be the answer for this question. C. State why thermal energy is transferred by conduction through the glass surface of the lamp. 1 mark. So for this question, it is about conduction. So your answer should be also the description of conduction here. Okay, so how to answer the question here, which is the molecules in the glass have strong intermolecular force of attraction. Okay, so we need to mention this, okay, to indicate that the molecules cannot move freely. Okay, so since they cannot move freely, what happens is they pass the thermal energy to the top neighboring molecules by vibration. Okay, so causing them to vibrate more rigorously. And then the process is called the transfer of thermal energy by conduction. Okay, so this is how it works. And I think you don't have to write too long because this is just a 1 mark question. So just maybe 2 or 3 sentences will be more than enough. Question 6. 5 components of the electromagnetic spectrums are listed as below here. We have radio waves, microwaves, visible light, X-rays, and gamma rays. A. Part 1. 2 other components of the electromagnetic spectrum are missing from the list. Write the names of the missing components in the appropriate rows in the table 6.1. So 2 marks. So what we need to do is we need to write down the names of components into these 2 cells with the hint that the first component has a wavelength of 1 times 10 to the power negative 7 meters. For the second component is 1 times 10 to the power negative 5 meters. So the wavelength for the first component is shorter than the wavelength of the second component. Okay, so now let's check all the components written here. Which component are missing? Okay, so the first component is between microwaves and the visible lights. Okay, what is it? Yes, it is the infrared. Okay, so another component, can you identify where is it? Yes, it will be between the visible light and the X-rays. So what component is this? It is the ultraviolet. Okay, so once you have identified these 2 missing components, the next question is which one to write? Well, maybe which one has the shorter wavelength. Okay, so now maybe to think about it, of course we don't really memorize the actual wavelength here, right? But we can think about this way, right? So the wavelength from left to right. The question is it getting shorter or longer? Now, how to tell? So what you can do is, right, you just look at the first component here, which is the radio waves. So what we use is radio waves. So we use this for the signal transfer, right? Okay, so that means why we use the radio waves as signal transfer? Because they can travel long distance. Now check the last one, the gamma rays. So this gamma ray can penetrate living cells. Okay, so what does it mean? It means that when the components from left all the way to the right, the wavelength will become shorter. Okay, we need a long wavelength so that the component can travel at longer distance. And we need to penetrate very, very small object, maybe like small living cells. Then this component need to have a very, very short wavelength. Okay, so now from here we know that infrared has longer wavelength than ultraviolet. So this is shorter, this is longer, then this component will be ultraviolet and this component will be infrared. Part 2. State one component of electromagnetic spectrum there is an ionizing radiation. 1 mark. Okay, so as you can check, for all the components in the electromagnetic spectrums, there are 2 components which are ionizing radiation. So they are the X-ray or the gamma rays. So your answer just need to write one of the components is more than enough. Okay, now next one, part 3. State one use of an ionizing radiation. Also 1 mark. Okay, so there are many usages of ionizing radiation. Okay, so maybe you just need to write one. Okay, so Now let's think about the usage of the X-rays. So X-rays can be used for luggage scanners in airport, or detecting cracks in pipes and buildings, or radiography. Okay, so the radiography is the one that let's say we go to hospital, we say we want to take X-rays, right? So it is the radiography. Okay, we also can think about the use of the gamma rays, so which are sterilization of medical equipment or kills cancerous cells in radiotherapy. Okay, so you just need to write one of these answers. B. All electromagnetic waves transfer energy and travel through a vacuum at a speed of 3.0 times 10 to the power 8 meters per second. Part 1. State one other property common to all components of the electromagnetic spectrum. 1 mark. Okay, so the very obvious property that common to all components of the electromagnetic spectrum is they are transverse waves. Okay, you can just mention all components of the electromagnetic spectrum are transverse waves. Then move on to part 2. The wavelength of a microwave is 2.0 times 10 to the power negative 2 meters. Calculate the frequency of this wave. So this is a 2 marks question. So to calculate the frequency, then we can use the wave formula V equals to F lambda. So to calculate the frequency, then F will be equals to V over lambda. So the V is a speed which is 3.0 times 10 to the power 8, and the wavelength of this microwave given is 2.0 times 10 to the power negative 2. So we calculate, we'll get 1.5 times 10 to the power 10 Hz. Hence 1.5 times 10 to the power 10 Hz is the answer. Question 7. A. When a glass television screen is rubbed with a soft cloth, the screen becomes positively charged. 1. Explain how the screen becomes positively charged. 1 mark. So this question basically asks how an insulator is charged by rubbing. So the answer is electrons from the screen are transferred to the soft cloth when rubbing, causing it to lose negative charges. Hence, it becomes positively charged. Do note that only electrons can be transferred from one atom to another atom. 2. Uncharged particles of dust in the air near the screen, shown in figure 7.1, are attracted to the screen and soon make it dusty. Explain why the particles of dust are attracted to the screen. You may draw on figure 7.1 if you wish. 3 marks. Now, so what do we need to draw on figure 7.1? Yes, we need to draw the charges on the dust particle. So the surface that close to the glass television screen will mark negative charge because the glass screen is positively charged, hence it will attract the electrons towards it. And the surface of the dust particle, which is away from the glass television, will have the positive charge. Okay, the reason is because the electrons has been attracted to the glass television screen, hence left behind with the positive charges. So the answer for this question is when the dust particles come near to the positively charged screen, the electrons on the particles are attracted to the screen and move towards the surfaces of the dust particles that are closer to the screen. Hence, these surfaces becomes negatively charged. As unlike charges attract, the dust particles are attracted towards the screen by the forces of attraction, hence make it dusty. B. A student charges a glass rod and a plastic rod separately by rubbing them with different cloths. The glass rod is charged positively. She places the glass rod on an insulator on top of a balance. When the plastic rod is held above the glass rod, the reading on the balance increases, as shown in figure 7.2. 1. Explain why the reading on the balance increases when the plastic rod brought close to the glass rod. 1 mark. Alright, so I think the answer is quite obvious. Okay, the reason is because a force pull the glass rod downwards, making the reading on the scale increases. Okay, so why it is being pulled downwards? The reason is because very simple, because the plastic rod is also positively charged. Since like charges repel, the glass rod is repelled by the plastic rod, causing it to exert a downward force on the balance. Part 2. State how this experiment shows that there is an electric field around the plastic rod. 1 mark. Alright, so in part 1, we explained that there is a repulsion force that pulls the glass rod downwards, making the reading on the balance increases. Now the question is, what produces this repulsion force? Okay, so the repulsion between the two charged rods shows that there is an electric field induced around the plastic rod that causes the force of repulsion. So that's the reason. Question 8. Two metal rods X and Y are connected to a resistor R and a DC power supply. Each rod passes through a hole in a cut which is horizontal as shown in figure 8.1. There is an electric current downwards in each rod. A. On figure 8.2, draw the pattern of the magnetic field around and between the two holes. Mark the direction of the magnetic field lines on your pattern. 3 marks. So the question states that there is an electric current downwards in each rod. So on figure 8.1, we can draw the direction of current which is flowing downwards. So which indicates that on figure 8.2, the two holes there, we can draw crosses inside, which indicates that the current is flowing into the cut. So next, we use the right hand grip rule. So use your right hand, hold it as a thumbs up, and then the thumb is pointing onto the cross. So the thumb shows the direction of the current, and the other fingers will show the direction of the magnetic field lines. Hence, as you can see from here, the magnetic field lines are in clockwise direction. So we know the direction of the magnetic field lines is in the clockwise direction. Now we can start to draw the magnetic field lines on figure 8.2. So first thing we need to do is we draw the two circles near, very close to the two holes, and it is in the clockwise direction. Alright, so what's the reason? Because this indicates that the magnetic field lines in this region is very strong. So next we draw another two circles which is slightly further away from the two holes and also in the clockwise direction. Okay, so indicate that the magnetic field line here is slightly weaker than the first circle. Okay, now next one, the third layer. As you can see from here, right, we don't draw two complete circles, but it is something like these two circles combined together, make a number 8 shape like this. Alright, and as you can see, there is no magnetic field lines between the two circles at this layer, right, because the two magnetic field lines have been combined. So another layer, so which is very similar with the third layer, but again for this layer it is more away from the two holes, hence the magnetic field lines are more weaker. Alright, so do indicate in your drawing, right, when the magnetic field lines are further away from the two holes or the two metal rods, it will be weaker and hence the distance is further away. B. Each of the rod has a resistance of 1.0 ohms. The DC power supply has a voltage of 12 volts and contains a circuit breaker that allows a maximum current of 6.0 ampere. 1. The current in resistor R is 6.0 amperes. Calculate the resistance of R. 3 marks. So from the diagram, we can see that the two metal rods are connected parallel. So we let R1 and R2 as the resistances of each rod respectively. Then we need to calculate the equivalent resistance of these parallel resistors. So apply this formula, 1 over R equivalent equals to 1 over R1 plus 1 over R2. Then we substitute the values, both R1 and R2 have the same value, which is 1 ohm. So it will be 1 over 1 plus 1 over 1, which gives us 2. Hence, the equivalent resistance will be 0.5 ohms. Next, we use the Ohm's law, V equals to IR, to calculate the resistance R. So the R is connected in series with the R equivalent. Then the equation becomes V equals I multiplied with R plus R equivalent. Then we make R plus R equivalent to be the subject. It will be equals to V over I. Now to calculate the R, it will be V over I minus R equivalent. And now we can substitute the values. V is 12 volts, I is 6, and the R equivalent is 0.5. We get the R value will be 1.5 ohms. Hence, 1.5 ohms is the answer. Part 2. State one advantage of using a circuit breaker rather than a fuse. 1 mark. So just need to write one advantage of using a circuit breaker compared with a fuse. So a circuit breaker can be reset and reused after trip. However, a fuse must be replaced after melted. Question 9. Question 9. Figure 9.1 shows the circuit used to take the measurements for the current and voltage characteristics of a solar cell. The cell is illuminated by light of a constant brightness. As the resistance of the variable resistor is altered, current I and voltage V are measured. Figure 9.2 shows a sketch of the I-V characteristic graph obtained. On figure 9.2, for a particular brightness, point P shows the maximum current the cell can produce. Point R shows the maximum voltage the cell can produce. At point Q, the cell is producing its maximum power output. Table 9.1 shows values of maximum current, maximum voltage, and maximum power output for 5 different brightness levels of the light shining on the cell. The brightness is measured as the number of joules of energy per second, which is watt, falling on an area of 1.0 meters squared. A. State whether switch S1 and switch S2 are open or closed to obtain readings for points P and R. 2 marks. Okay, so let's study what information is given here. So for point P, it shows the maximum current the cell can produce. So maximum current means it is a short circuit. Hence, to make the circuit short circuit, switch S1 has to be closed and switch S2 has to be closed as well. Now, for point R, it shows the maximum voltage. So maximum voltage means it is an open circuit. Therefore, to make the circuit to be open circuit, then switch S1 has to be open and switch S2 has to be open as well. B. A solar panel contains several solar cells connected together. The output is used to charge a battery. Figure 9.3 shows one arrangement of 4 solar cells in a panel. Part 1. Use data for light of brightness 1000 watt per meter square in table 9.1. Calculate the maximum output voltage of the panel. 1 mark. So from table 9.1, we need to look for the brightness of 1000 watt per meter square. So it will be in the last row. In table 9.1, they tell us that the maximum voltage is 0.59 volts. And then we look at the figure 9.3. There are 4 solar cells in the panel. Hence, the maximum voltage of the panel will be 0.59 times 4, which gives us 2.36 volts. Hence, the answer is 2.36 volts. Part 2. Use your answer to B part 1 to calculate the maximum current in a resistor of resistance 2.0 ohms connected in series with the solar system. 1 mark. So to calculate the maximum current, we will use the Ohm's law, V equals to IR. So the maximum current, Imax, is voltage maximum divided by the resistance. So the Vmax, we have calculated in part 1, which is 2.36 volts, and the resistance given is 2 ohms. Therefore, the maximum current is 1.18 ampere. Hence, 1.18 amperes is the answer. C. Part 1. State what is meant by the efficiency of a solar cell. 1 mark. Okay, so to answer this question, we can relate to the formula of efficiency, which is P out over P in, and apply to this example here. Okay, so for this case, the output power is the electrical energy, and the input is the light energy. Okay, so we can say that efficiency is the ratio of useful electrical energy output to light energy input. Part 2. State why the efficiency of the solar cell is 0 at points P and point R on figure 9.2. 2 marks. So the reason is because energy output can be calculated with the formula E equals VIT. At point P, voltage output is 0 because it is short circuit. At point R, current is 0 because it is open circuit. So if you look at the formula E equals to VIT, whether V is 0 or I is 0, both cases will give you 0 energy. So both cases produces 0 energy output, and hence efficiency is 0 at point P and point R. So remember, efficiency, as we have answered in part 1, it is the ratio of useful electrical energy output to light energy input. So when output is 0, efficiency will be 0. Part 3. Light brightness 1000 watt per meter square shines on a single solar cell. The efficiency of the solar cell at maximum power output is 18%. Using the maximum power output of the cell in table 9.1 and the efficiency, calculate 1. The number of joules of energy per second falling on the cell. 2 marks. So based on table 9.1, when the brightness is 1000 watt per meter square, the maximum power output is 2.0 watt. So write it down. The maximum power output equals 2.0 watts from table 9.1. Then we use the efficiency formula, which is equals to power output over power input. So given that the efficiency is 18%, which is 18 over 100, and the power output is 2.0 watts from table 9.1, we want to find the power input P in. Hence, rearrange the equation. P in will be equals to 2.0 times 100 divided by 18, which gives us 11.1 watts to 3 different figures. So the answer will be 11.1 watts. Two, the surface area of the cell. 1 mark. So to calculate the surface area of the cell, we need to look at the ratio of the light brightness here, 1000 watt per meter square. So what does this mean? This means that every 1 meter square, the light brightness is 1000 watts. So in part 1, we have calculated the power is 11.1 watts. Okay, so 1 meter square is to 1000 watts. How many meters square is to 11.1 watts? So we use this ratio method, right, to calculate the surface area of the cell. So it will be 11.1 watts divided by 1000 watt meters per second per meter square. We'll get 0.0111 meter square. Hence the answer will be 0.0111 meter square. Then part 4, explain in words how the data in table 9.1 shows that the efficiency of the solar cell at maximum power output does not depend on the brightness of the lights. So this question is 1 mark. Now in table 9.1 we can observe that the maximum power output is proportional to the brightness. Okay, so now look at here, the brightness when it increases, the maximum power output also increases. So this will be proportional to this quantity. Okay, so the efficiency of the solar cell will remain constant and does not depend on the brightness of the light. Okay, so remember the formula of the efficiency will be power output divided by the power input. So if power output is proportional to the power input, which is brightness for this case, then the efficiency will remain constant. Question 10. Figure 10.1 shows the structure of a transformer. The primary coil is connected to an alternating current supply and the output of the secondary coil is connected to a cathode ray oscilloscope (CRO). A. Part 1. State what is meant by alternating current. 1 mark. So what you need to do is just write down the definition of alternating current, which is alternating current is the current that the direction of the current flow changes several times a second at regular interval. Then part 2, explain why there is an output voltage produced in the secondary coil. 3 marks. So this question carries quite a high marks, which is 3 marks here. You need to explain detail how the voltage is produced in the secondary coil. So there are a few pointers that you need to mention here, and I bold the important keywords in the answer here. Okay, so when an alternating current flows through the primary coil of the transformer, it creates a changing magnetic field around the coil. According to Faraday's law of electromagnetic induction, this continuous changing magnetic field induces a voltage in the secondary coil. B. Figure 10.2 shows the screen of the CRO. The time base of the CRO is set at 10 milliseconds per division and the Y gain is set at 5 volts per division. The number of turns on the primary coil is 4 times that on the secondary coil. Part 1. Calculate the frequency of the alternating current. 2 marks. So before we want to calculate the frequency of the alternating current, first we need to determine the period of the alternating current. So from the screen of the CRO, this is the period of the alternating current. Okay, so this is the one complete cycle. So you take 4 divisions from the screen to complete the cycle. So now the period T will be 4 divisions and the setting is 10 milliseconds per division. Therefore, the period will be 4 divisions multiplied with 10 milliseconds per division and we'll get 40 milliseconds. So 40 milliseconds means it's 40 times 10 to the power of negative 3 seconds. So we use this value to calculate the frequency. F will be 1 over T, which is 1 over 40 times 10 to the power of negative 3 and we'll get 25 Hz. Therefore, frequency is 25 Hz. Then part 2, state the equation that relates the voltage output Vs, the voltage input Vp, the number of turns Ns in the secondary coil, and Np, the number of turns in the primary coil. So 1 mark. what you need to do to answer this question is just write down the equation of the transformer, which is Vs over Vp equals Ns over Np. Part 3. Calculate the amplitude of the alternating voltage supplied to the primary coil. 2 marks. Okay, so this question you have to be careful because figure 10.2 shows the voltage outputs Vs only. Okay, so we need to find the alternating voltage from the primary coil. Okay, of course, we will start with the figure 10.2. So from figure 10.2, we can find the amplitude Vs, which is this is the amplitude which takes 2 divisions, and the setting is 5 volts per division. Hence, is 2 division multiplied with 5 volts per division, we get the amplitude of the secondary voltage is 10 volts. Okay, but don't stop here. We need to find Vp. So we use the formula of transformer Vs over Vp equals Ns over Np to calculate the Vp. Okay, so we substitute the value Vs as 10 and over Vp, which is the quantity that we need to find. So next one, Ns over Np, given that the number of turns on the primary coil is 4 times that on the secondary coil. So which means that the ratio Ns over Np will be 1 over 4. Okay, so once we form this equation correctly, then we can solve this equation to find Vp. It will be 10 times 4, which gives us 40 volts. Hence, the amplitude of the alternating voltage supplied to the primary coil will be 40 volts. Question 11. Either light is incident normally on a glass prism as shown in figure 11.1. The refractive index of glass is 1.5. A. Define the term refractive index in terms of the speed of light. 2 marks. Okay, so just write down the definition of refractive index in terms of the speed of light, which is refractive index is the ratio of the speed of light in a vacuum to its speed in the medium. B. The ray of light passes through the prism and leaves the prism at point P. The angle of incidence of the ray at point P is 30 degrees. Part 1. On figure 11.1, draw the normal to the glass surface at P, the angle of incidence at P, and the path of the light as it leaves the prism. 2 marks. Okay, so first we need to draw the normal to the glass surface at P. So normal is always perpendicular to the surface. Hence, draw a dotted line that represents it is a normal, and this dotted line is perpendicular to the surface. Alright, so label this dotted line as normal line. Now next one, I will need to label the angle of incidence at P. So angle of incidence measured from incidence ray with the normal. Hence, this is the angle of incidence, and don't forget to label, I'll mark it as I and indicate that I equals to the angle of incidence. Okay, now next one, I want to draw the path of light as it leaves the prism. So since the light travels from denser, optically denser medium to less denser medium, hence it will bend away from normal when it leaves the glass. So draw this ray which is bent away from the normal and label it as the path of light as it leaves the prism. Part 2. Calculate the angle through which the ray is deviated from its original direction as it leaves the prism. Show your working. 3 marks. Okay, so to answer this question, we can use the formula n equals sine I over sine r. But you have to be careful when use this formula because this angle of incidence and angle of refraction, yeah, they are different from the I here. Okay, because this I and R is the angle when the ray enters the prism. So in other words, when the ray enters the prism, it will follow the same path, but the I is this angle and the R is this angle. Okay, so let's have a quick recap here. A ray will follow in the same path when traveling in opposite direction. So in other words, now if the ray follow this path, it will bend towards this line. Okay, now given that the n is 1.5, which is this one, so this I is the one that we need to find. So I leave it as sine I, and then the R here is this angle, so which is 30 degrees. Alright, so it's given here 30 degrees. Now sine I will be 1.5 times sine 30 degrees, which gives us 0.75. So from here we can find the angle I, which is inverse of sine 0.75. We get 48.6 degrees. Is the answer is 48.6 degrees? Actually it is not, because the question is asking us what is the angle that is deviated. Okay, so deviated means, right, so this angle is 48.6 degrees, which I have found here, and this ray is supposed to move in a straight line, but it deviated into this path. Okay, so this angle will be 30 degrees because it will be same as this angle. This is vertically opposite angle. So I want to find this angle as the angle of deviation. Okay, so to find the angle of deviation, it will be this angle 48.6 degrees minus 30 degrees, which gives us 18.6 degrees. Hence, the answer is 18.6 degrees. Okay, so a very tricky question. You have to be very, very careful. C. Light is incident normally on another glass prism as shown in figure 11.2. The prism is made of the same glass as the prism in figure 11.1. The ray of light is totally internally reflected in this prism. Part 1. On figure 11.2, draw the path of the light as it passes through and emerges from the prism. 1 mark. Okay, so to complete the ray diagram in figure 11.2, so when the ray of light enters the prism, it is perpendicular with the surface. Hence, it will just move straight without any bending because it is perpendicular with the surface. Okay, now when it hits the surface, it is totally internally reflected. Okay, so what we need to do is we draw a normal line. Okay, the normal is perpendicular with the surface, and then it will totally internally reflected. So when it reflects, the incident angle, which is 45 degrees, will be same as the refracted angle. This will be 45 degrees. So we complete this ray, this will be 45 degrees. Alright, when you go out, this is another perpendicular. The ray is perpendicular with the surface, hence it will still go straight. So this will be the complete ray diagram. Part 2. Explain why the light is totally internally reflected. 2 marks. Okay, to answer this question, you just need to describe how totally internally reflection happen. So when a ray travels from an optically denser medium to an optically less dense medium, it bends away from normal. When the incident angle equals to critical angle, the refracted angle will be 90 degrees. When the incident angle is greater than the critical angle, total internal reflection happens. Okay, so this is the answer. I have bolded the important keywords that you should write in your answer. Question 11 or question. A. Physical quantities such as the resistance of a metal wire are used to define temperature scales. Explain how this is done for the Celsius scale of temperature. 3 marks. Okay, so to answer this question, basically you just need to mention what is the thermal properties that we use to measure temperature, and also how do we calibrate a thermometer. Okay, and the unit is in Celsius, means that we will refer to the freezing point and the melting point of water. Okay, so here is the model answer. The physical quantities that are used to define temperature scales must have thermometric property that varies linearly with temperature. To define a temperature scale, two reference points, the lower fixed point and the upper fixed point, are needed for calibration. For Celsius scale, the readings of the physical quantities at ice point, which is the lower fixed point, and steam point, which is the upper fixed point, are marked. Divide the range of temperature between these 2 points into 100 equal intervals to obtain a scale of 1 unit as 1 degree Celsius. B. An electric kettle is used to heat water to make hot drinks. The specific capacity of water is 4,200 joules per kg degree Celsius. Part 1. State the unit for heat capacity. 1 mark. Okay, so the unit or the SI unit for heat capacity will be joules per degree Celsius. Now part 2. Some of the water heated by the electric kettle is left in the kettle and is not used to make hot drink. This water is heated unnecessarily. One household heats on average 1.2 kg of water unnecessarily every day. Calculate 1. The energy in joules used to warm 1.2 kg of water from 20 degrees Celsius to 90 degrees Celsius. 2 marks. Alright, to calculate the energy, we use the specific heat capacity formula, Q equals to mc delta T. So given that the mass is 1.2 kg, the C is 4,200 joules per kg degree Celsius, and the change of temperature is from 20 degrees to 90 degrees Celsius, hence it will be 90 minus 20, and we'll get 352,800 joules. So 352,800 joules is the answer. Now, number 2, the energy in kilowatt hour wasted in 1 year by the household in heating water unnecessarily. 2 marks. Alright, so we want to represent the energy in different unit, which is kilowatt hour. So 1 kilowatt hour will be how many joules? It will be 1000 watt times 3600 seconds. Okay, remember kilowatt hour means that 1000 watts is used in 1 hour. Alright, so convert to energy will be 1000 watts times if 1 hour, which is 3600 seconds, and we will get 3,600,000 joules. Now energy wasted a year, it will be the energy we calculated in part 1, which is 352,800 joules divided times the 365 days. Okay, because in part 1 it is in a day, so I want to convert a year, we have to multiply with 365 days, and the unit is in joule. I want to convert into kilowatt hour, hence I will divide it with 3,600,000, and I will get 35.77 kilowatt hour. Hence 35.77 kilowatt hour is the answer. Part 3. State 2 reasons why the actual quantity of energy supplied to the electric kettle to heat 1.2 kg of water to 90 degrees Celsius is larger than the value calculated in B, part 2, 1. Okay, so what's the reason that we underestimate the energy needed to heat 1.2 kg of water to 90 degrees Celsius? Okay, so the first reason is because there is energy lost to the surrounding as heat. And the second reason is because some of the thermal energy is used to hit the cutter. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.